Okay, hi everybody. Hopefully it's still okay for you to have a look at this. So I'm going to present today the Kipu Quantum Hub platform. This is a platform that we designed for customers to, let's say, act as a one-stop shop for all the needs that customers have in the quantum systems. But let me first do an introduction into what is the actual customer need and where we started with this. Just a brief overview about the company. So we are Kipu Quantum. We are a startup in the quantum computing space. So we design and build quantum algorithms for various use cases and applications. So we work with customers on industrial applications and delivering the value and showing the benefit of quantum computing in the various use cases that customers have. We are focusing in three main areas, so optimization, machine learning, and simulations. In all of these three areas, we have already developed algorithms, or let's say cutting-edge algorithms that deliver value to customers, running only on quantum machines. So we're focused on delivering value on real quantum hardware. You can see some of the hardware players that we already integrate with. So all of the major hardware providers that exist in the world, in the quantum world, are already integrated by Kipu, and we already designed algorithms in mind with the hardware. I'll talk about this in a second. And then in terms of commercial success, so by now we have a broad portfolio of clients where we have already implemented commercial projects in the various use cases. So you can see some of the logos here, very well-known companies, including the automotive, transportation, logistics, energy, telecommunications, banking as well, and of course the chemicals and oil and gas. Yeah, just a few words also on in terms of what we provide. So we provide algorithms, we provide services, and we also provide a platform. Platform is what I'm going to show you today. And when we have been talking to customers, one thing that we identified is the visualization of quantum. So many customers, especially on the business side, they say, okay, this is all great, but how do I explain this to my management? How do I explain it to people who have no clue about quantum computing? So that was the initial need on why we developed a platform. Key question, how to visualize quantum. So if you look at a typical organization or a typical government body, the way they will most likely look at building a thriving quantum ecosystem within their organization is the following. So you would start with the exploration phase. So this is, let's say, where most of the organizations are right now, where first you understand the technology, second you start identifying small use cases and start actually probing and doing something there in terms of proof of value projects. So that's the first stage. The second stage is where you start deploying the first use cases. So you're basically going on the market, you are searching for those experts who are able to help you with implementation of these use cases, and then you select a couple of pilot projects and you also start investing into the infrastructure. So that's the second, let's say, maturity stage of an organization. And then the third stage is how you expand and how you move to industrialization or prepare for industrialization. So of course that means that in your business, especially in the large enterprise, you would want to enable the various stakeholders inside the various business units on quantum. So not only building your own quantum team, but actually going into the departments and getting the champions trained, quantum champions trained on the quantum technologies. This is also an important part of developing quantum ecosystem within organization. And then finally, monitoring and adapting, so developing the strategy and adapting your quantum, let's say the quantum implementations within the organization. So that's briefly how we see that the customers are developing at the moment. Some of the customers are in the first stage, some are in the second stage, and very few are in this scaling stage at the moment, worldwide, I would say. So to cover all of these needs, we developed a platform which basically provides everything that you would require, starting from access to hardware, then accessing the algorithms, accessing business applications, and then eventually also applying AI. So that's obviously the latest trends. And many customers ask this question, how to enhance AI with quantum, and how quantum and how AI can enhance quantum as well. So both ways, let's say, how to enhance one with the other one, and how to enhance the other one with the other one. I hope I can demonstrate this to you in a second. So some of the innovations we've done in this space as well. Let's see, because the setup wasn't designed to do live demos, but that's what I'm essentially trying to do here. Okay, key capabilities of the platform that we developed. So you get access to the hardware, you get access to algorithms, you have collaboration tools, so cross-collaboration tools to enable the company and enable the collaboration between the various parties, AI integration, and hosting the use cases. And hopefully, yeah, hopefully I can show this to you in a second. Maybe you can press the escape button, and then we can go straight into it. Cool. Okay. So this is the Kipu platform. Let's hope it's loading here. If not, I have a backup. Try this instance. Yeah. Okay. So this is the Kipu Quantum Hub platform, and as I mentioned, it has several layers to it. The first layer is the hardware access. So basically, you have various quantum machines that are available to you. And if you are an organization that wants to explore not just one technology, but multiple technologies, this is an easy way how to access the quantum hardware, cutting-edge hardware that is available on the market. So basically, you can, instead of contracting each of the hardware providers, you get access to the Kipu Quantum Hub, and then you can use with your hardware credits the various platforms that are available there on the market. So instead of contracting many parties, you just contract one. This, of course, also requires for the use case implementation the mix of classical. So this platform here also gives you the access to the classical machines as well. There is orchestration layer. So let's say on the technical level, you have everything that is needed to be able to start with quantum, at least from the hardware point of view. So that's the first layer. The second layer is the algorithms. So let's say you get access to the hardware. Now what? The next thing is to start exploring and building something on top of this hardware. So hardware itself is not going to help you develop the use cases. And this is where the algorithms part comes in. So you have here multiple algorithms. Some of them are from third party, some of them are freely available. And we also publish here the cutting edge algorithms that Kipu developed. Currently, we are developing algorithms in three main areas, as I mentioned. So we have optimization, these ones here. There is also machine learning algorithms that we published, and there is also work that we do in the simulation area. So algorithms are very easy to access. There is good documentation. You can get good descriptions, and eventually you can connect this either through the API or through publishing an application, which is the next thing that I'm going to show you. Okay. So this is the use cases. The use cases it's essentially a library of the various business use cases that have already been implemented on the platform. Some of them are public use cases, and there is also the private space. So let's say if you have an enterprise that wants to develop a specific application for their own internal needs, this would be published here, but in the private space, so that only the organization would have access to it. And you can see here various use cases, and of course, being in Dubai, maybe we take this one, so maritime vessel traffic management. So we actually built, for Abu Dhabi port, we built a live demo that maybe I can show you now. So basically, you are entering the use case, you get a problem description, you also have a description of how quantum can help in this particular problem. And then if we look at the demo itself, so while it's loading, what we're trying to do here is to build a layer on top so that quantum can be visualized. So the algorithms and the business application that was built, then we have this visualization layer on top so that it's easier for customers, especially on the business side, to be able to understand what does quantum actually do for an enterprise, how quantum can be useful. For the sake of this exercise, I'm going to load an example here. And you can see the Abu Dhabi port and the various ships. So there is 16 ships with the 16 routes that we are looking at here. The problem that we have with these 16 ships is that all of them need to enter the harbor. Harbor being the bottleneck, so the narrow part. And the challenge is if all of them go in at the same time, then eventually there might be a crash because their routes are intersecting. So what we're doing here is I've loaded an example. Obviously, I could do this manually, but for the sake of exercise, I've loaded an example here, and then I'm asking the system to optimize the routes of these ships. So hopefully, guys can bring this up, and I hope you don't have to change anything again. So what I've done while it's not being visible on the screen is I've asked the system to optimize the routes. And here you see the output. So basically the system has done the analysis and said, instead of doing a sequential entry into the port, because that's the only way to avoid crashes, we can guide the ships to coming into 3 main slots. Slot 1 is from 8 o'clock to 10, then another slot from 10 to 12, and then another slot from 12 to 14. So what the system has done is we're using a mathematical formulation to move the problem into the Hubo space, so higher order binary unconstrained problem. And this allows us to do the analysis and eventually optimize the routes with the proposal that is given here. So 3 slots. And for each of the slots, you have a number of ships. For the first slot, 9 vessels. For the second slot, 6 vessels. And then for the third slot, only 1 remaining. And apparently, that's what the system thinks could be done in order to avoid collisions. So within each slot, all of these ships don't have the intersecting trajectories, or let's say the intersecting routes. So this allows us to bring in all of these ships, 9 ships in the first slot without causing collision. So that's how quantum can be visualized, and this is how we help customers to bring and explain the quantum to the senior stakeholders at the company and to those who make decisions about the company strategy when it comes to innovation. Okay, any questions so far? Otherwise, we can talk about AI and some of the applications there. Okay, cool. So I mentioned that we are already integrating AI into the platform, and one of the things that is also related to business is maybe helping those who are less quantum savvy to understand how can quantum be applied to their organization. So let's say I'm from Abu Dhabi ports, and I want to I need help to understand how to apply quantum in my business. So what I'm doing here is a typical style, well-known style of the prompt. I'm asking the system to help me a bit. And you might say, okay, but how is this different from ChatGPT? Well, the difference is that we are blending the publicly available data with the knowledge that has been accumulated by our company, because we've done so many use cases already and we know the applicability. So what the system is doing, unlike ChatGPT, it's giving you a list of use cases. So you can see here, for example, supply chain. You see a velocity profile of cargo ships. So it really describes on a very high level what the problems could be that the quantum is solving or helping to solve. And then it also gives a ability to dive into a bit deeper. So it's giving you references to papers, and then it also gives you the reference to the algorithms that could be used to build a specific application. Maybe we can, I don't know if I have a query here. The problem is I don't have the keyboard, so I could show you a bit more, but I think this is already enough to get an understanding of how this algorithm is working. Okay. This is where I will pause, and maybe one more thing. We're also developing an algorithm that will support reasoning models. This is another potential application of quantum computing, but this is more in the AI space. So how to help LLMs make better decisions based on quantum optimization. Okay, cool. I will stop here, and I will take questions. Hopefully this was useful, and hopefully there is something that you can take out from this session. Thanks a lot. Yep.
How many large sizable?
Yeah, so this really, we are limited here by the hardware versus the algorithms that we have. So our algorithms are scalable, and the more hardware you get, the higher the problem that could be solved. We've tackled problems of 156 qubit size because that's the latest available on IBM machines. But we're actually doing 2 more things at the moment. Can you hit the escape button, please, once again? We are introducing 2 new concepts. One of them is called sequential quantum computing, and the other one is hybrid classical quantum workflows. So basically, the idea in the second one is to split the problem into smaller chunks and then apply classical to tackle a much bigger problem than what is currently available on the hardware market. And then another thing which I mentioned was sequential quantum computing. Let's have a look if I can show you this. Yeah. Hybrid sequential quantum computing. So we're basically applying different quantum hardware within solving one problem. So having this benefit of multiple hardware, different hardware access on the platform, plus the classical as well, you will be able in the future to combine these workloads into solving one problem, which is, it could be quite powerful because let's talk about business, not so much about quantum, but for the business. You might have a use case that could benefit both from optimization and also from machine learning. And in that case, for optimization, you might like to use one piece of hardware because IBM, for example, is best on optimization, whereas for machine learning, you might have another piece of hardware that you might like to apply to it. So that's what we call sequential quantum computing, where parts of the workflow are executed on the various quantum machines, eventually to extract the maximal business use. Yeah. I can already see you are thinking how to. We have here a partner / competitor from Classic, and he's snooping on things to see how this can be also. We do the same as well, by the way. So thanks for the compliment. Okay.
So the ship scheduling that was there.
Yeah.
So does that happen real time? So like in a scenario where 10 ships are at the near to the port, and if we run the algorithm, does it happen in real time and it schedules all the ships?
Okay, so for this exercise, if I was to do it in real time, this presentation would probably cost me a couple of €1,000. So for the sake of exercise, I'm doing the simulation or emulation here. However, one thing that is really cool, and I don't think many can show off with this kind of experience at this point in time, but we have a customer in the automotive space, two letters in the name of the company, so they are a car maker with 2 letters in the name. And together with us, they built a first prototype where the optimization is done continuously of the logistics use case, and the optimization is refreshing every 30 seconds. So it's using a real machine, quantum machine, to do the optimization and demonstrate the result on the screen in real time. At the moment, we are limited more by hardware rather than by our algorithms. So on our side, this can run really fast. On the hardware provider side, we're still in the phase where if you buy the hardware, it still says available only for research. Why is that? It's because they cannot offer the SLAs that you would expect in the industry. So we're really bound here by the hardware providers versus what is available in the algorithms. And if you are, for example, IBM Premium customer, so this is, let's say, 200,000 and up in terms of costs a year, just for the hardware, then you get this premium access to their hardware, which allows you to execute more or less in real time, unless there is another premium customer that's submitted the job before, that takes a long time. Okay. That's why there is this latency or delay of 30 seconds or so, because there is still somebody in front of you in the queue, even if you have a premium plan. So that's, I would say, this is really the stretch of what's possible right now. The fact that you are able to refresh in real time every 30 seconds, that's already quite impressive. And that demonstration, of course, also has cost implications, because to be able to run it every 30 seconds is costing.
So the optimization which is happening, is it annealing-based optimization, or you're using IBM Quantum, the superconducting qubits?
Can you please repeat the question?
So the optimization which is happening, the ship scheduling or anything, does it happen on annealing-based optimization, like the D-Wave hardware, or is it happening on IBM's superconducting qubits?
We could design it on both pieces of hardware. So we support both D-Wave and IBM and many other machines, such as IonQ, QEra, and so on. That particular example, the one which was here, is based on IBM.
Okay.
Yeah. Yeah.
It's a personal interest question.
Sure.
So yesterday and today, I'm mostly seeing that. Thank you. So I'm mostly seeing that industry is mostly interested in gate-based quantum computers.
Yeah.
So from your own personal perspective, do you see measurement-based quantum computing catching up on the use cases at some point?
You mean non-gate based, so the other stuff, yeah. I think it really depends on the use case. We have seen pretty good results on machine learning use cases with D-Wave machines. D-Wave doesn't know about this, by the way. So, so they're positioning themselves as a company that does some kind of real quantum for optimization, and they can make available many qubits, so much more than 150. But at the end of the day, well, first of all, some people challenge whether it's real quantum. And the second thing is we don't use that for, so we are on optimization, we're focusing on other technologies such as gate-based. But it has a potential also from our perspective in some other areas such as machine learning. So we have algorithms that specifically work on D-Wave, where we see really impressive results, and we can already say we achieved quantum advantage specifically in machine learning. So we're able to demonstrate impacts such as higher accuracy than traditional machine learning methods on D-Wave.
Thank you.
Yeah, so I didn't answer your question really. I just mumbled, but I think the answer is there is still potential in non-gate based stuff, and it really depends on what the algorithm is.
Yeah. Thank you.
Yeah, thanks.
As of now, which is the best hardware to execute the software side?
Yeah.
Just to.
I would answer the question the same way as I just answered, but, so it's a similar question, but I think it's important to look at, from the best point of view, it's not so much about the speed and other things. This is my personal opinion, so it's not so much related to the presentation I did, but I can share my personal opinion. A lot also depends on accessibility and on what the ecosystem and market is doing. And at the moment, for example, IBM is a strong player in this ecosystem. So a lot of stuff is revolving specifically around IBM. The way they've been handling the ecosystem, the way they partnered with the various software providers such as us, so the ones who build algorithms, is quite unique, and I see other vendors are catching up. So I don't think there is a single best one, but you can also judge from the number of qubits. So at the moment, IBM is providing possibly the highest number of qubits available to you. Yeah.
One more question. I mean, what percentage is ready your system is to offer to the customer as of now?
It will never be even 90% because by the time I fly back home, we will have another algorithm published inside this platform. Why? Because out of the 70 or so people we have in the company, 90% are PhD scientists, and they're working day and night to create more algorithms. So by the time we finish this session and I fly back home, we'll have another much better algorithm available. So this is the speed, really. I joined the company 6 months ago. I cannot. It's shocking to see how much we advanced just in these 6 months.
Thank you.
Thank you. Cool. Thanks a lot for your time.